In this video, we are going to take a look at scientific notation. You've seen scientific notation most likely in your science classes, and your calculator has also probably spit out scientific notation for you before, but you didn't necessarily know what it represented. We're going to look at scientific notation now because it actually just deals with exponent properties. So what I want you to do is take your calculator and plug in 365 to the 6. So take a moment, plug that into your calculator. It spits out 2.364 ... and then all of a sudden there's an E and a 15. That's the way your calculator denotes scientific notation, is with this E. E is just a notation for it that your calculator gives you. It's not mathematically what it is. If your calculator ever gives you this E value, you then have to go and rewrite it into scientific notation. This just means 2.364 times 10 to the 15. So realistically, what I have to do is I have to take this decimal place and move it 15 spaces. Okay, you're really multiplying by 10 to the 15th, okay, which is 15 zeros. So within our scientific notation, there are a few rules that go along with it, and some vocabulary. This part up front here, that's called the mantissa. Not that you have to remember what the word is, but you have to know something about it. The mantissa, the value of it has to be greater than or equal to 1, but it has to be less than 10. It can never be a 2-digit number, because if it were a 2-digit number, you could move that decimal place one more spot over, and then in turn changing your exponent. So keep that in mind. The mantissa has to be greater than or equal to 1, but less than 10. And then 15 is also another vocabulary term, and we call that the characteristic. And the characteristic must be an integer. The characteristic tells us how many places we have to move that decimal. So how many zeros we're going to be adding at the end of it, or moving it in the other direction because we're multiplying by that many tens, or we're dividing by that many tens. So quick little synopsis of scientific notation. Keep in mind, if you have 128, and I ask you to write that in scientific notation, the decimal place usually starts at the back. We move it in 2 places. So this is 1.28. I had to move it in. Therefore, I have times 10 to the second. Okay. Vice versa, if I have 0.0000124, my mantissa has to be between 1 and 10, excluding 10. So I move it 1, 2, 3, 4, 5 places. So this would be 1.24 times 10 to the negative 5th, because now when I'm looking at this part here, I have to technically divide it by 10 5 times, which is why it goes in this direction. So make sure that you're able to go both directions when you're doing scientific notation. Okay, so that's just the basics of it. Now we're going to go into the exponential pieces of it. So here we have 2 multiplications. I'm multiplying 2 different scientific notation forms. The last thing that you're going to do is write it out long-handedly. Instead, what we're going to do is we're going to look at characteristics of multiplication. If you were to write it out long-handedly, you may be able to do it. However, there's going to be certain cases where you're not going to be able to work with something times 10 to the 1,278th power. You're not going to write that many zeros onto it. So much easier to actually just work with the process itself. These are times symbols. Okay, we usually use an X. That's just kind of the general way we do it. But this is all multiplication that's taking place here. There is no addition. There is no subtraction. So you just have to go through order of operations. It's multiplication. Does multiplication matter the order? No. So I'm going to combine like parts together. It's just multiplication. So I'm going to multiply those numbers together. The 6 times the 3. Well, that's just 18. Times 10 to the 12th times 10 to the negative 14. So I'm multiplying, and bases are the same. So what do you do with exponents? Add them. So it's 18 times 10 to the negative second. Now, this is not in scientific notation yet. Okay, this is not in scientific notation. This is a multiplication problem. If I want it in scientific notation, this mantissa has to be between 1 and 10. So my decimal that sits back here has to move in. So this is 1.8 times 10. Now, that decimal point had to move in, so something has to change with this exponent. So what I did is I have an extra factor of 10 in here, because 1.8, if I need to get this here back up to here, what I ended up doing was dividing this by 10, which means this part here has to be multiplied by an additional 10. Therefore, this then goes to the negative first. The mantissa had to get smaller, so my exponent had to get bigger by however many tens it had to get smaller by. Because it has to be consistent, it has to be the same thing. I can't just all of a sudden change my value. If I'm dividing this by 10, that's the same thing as multiplying this by 10 by adding that number of exponents to it. So 1.8 times 10 to the negative first is scientific notation 4. Real number form is just 0.18. We can do the same thing with division. Okay, division works the same way. We have exponents that we worked with division as well. The first thing I'm going to tell you, though, is get rid of the division bar or division sign and put it with the division bar. Put it as a fraction. So 3 times 10 to the 24th divided by 6 times 10 to the 13th. So since I now have a fraction, you can hopefully see this is the quotient property. So when I'm looking at dividing, again, it's all up and down. So I simplify where I can. 3 goes into 3 once, 3 goes into 6 twice. And then bases are the same. Now I subtract exponents. So this is 10 to the 11th. And then on the bottom I have 2. Okay, that looks kind of goofy. Well, realistically, what does this mean? This is 1 times 10 to the 11th over 2. So 1 divided by 2 is 0.5 times 10 to the 11th. If the times 10 to the 11th was in the bottom, we would give it a negative exponent. Scientific notation is the only time we use negative exponents. It's the only time it's simplified to have a negative exponent. Now, one last thing, make sure it's in scientific notation. My mantissa, however, is not between 1 and 10, excluding 10. So I have to move this decimal place one spot over. So what I'm truly doing is I'm multiplying that by 10. Since I'm multiplying that by 10, I have to divide this part by 10, which makes it go to the 10th. Since my mantissa got bigger, my exponent got smaller. Because again, I'm just looking at an expression and I can't just all of a sudden change it. So you're going to have some practice problems with this, making sure that you get used to how do you work with those exponents, and specifically in the end, making sure that mantissa is between 1 and 10, excluding 10.